All right, we're back. This time we're going to go with from the bottom up. These are the Rxb demos. So like this is vput. Vput is a assembly language routine. It puts a string onto the screen. Let's say like print does or display it. But there is a difference. And the difference is that. Right now what it's doing is, if you look at what's going on, whoops. It clears the screen, and it has a vertical character, and it puts these on screen. Now, Rxb's H character is different than what you see with Extended Basic. Extended Basic, you can only do the row, column, character, and the number. And you can't put a comma and keep going. You can do that with Rxb. As long as you have the last one is the repetition, it might have to be a 1 if you want to go for the next one bunch. So that's the difference. And the next $, I'm going to put this string, then I'm going to put vput, which puts this on the screen, which is these characters. But then it's going to go and it's going to do the next thing, which is Y $, this is fast, and it's going to put that on the screen. Then it's going to go to 120, and it's even going to reload the string from scratch both times. That's to slow it down. You wouldn't see much of anything happening if I didn't have this X $ and Y $ in here. If I took those out and moved this down, it would be so fast you wouldn't even see what's going on. Even worse, what I can do is if I could do this, I could take this right here and I could add in this vput right here and just make it do one command. It would be so fast you wouldn't even see it happen because it's all in assembly. It would be instantaneous. It would just be an overlap of the characters. At least this you could see what's going on. So that's this. All right. And then we have, whoops, let me go to the top here. Then we have vget. Now, vget is, I was going to make this a assembly language, but, well, I did make it assembly, sorry. It was assembly language. Get character is still GPL. I tried to make get character into a assembly language routine, but it wasn't any faster. So I gave up on that idea. So let's do this. Okay, so this is going to do, it's going to get a character off the screen, whatever it may be. So just go like, we'll go size. All right, then I'll load the program. And it's going to jump to, whatever is it, 12, 16, four characters. So if we run it, that's what it did. See what there? It gets the characters, the 4 characters at 12, 16. We count down, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's getting somewhere in here. And what it's getting is the characters there, the 4 characters. It looks like a V or something. Or then it puts at, oh, it's putting the X $ there. And then it gets, then it puts at 12, 16, in just a random set of characters. Then it goes back to the top one and does it over again. So this is what you're seeing. And you're just seeing how fast it is. It's very quick because all of these right here are all assembly. It's not a great demo, but at least it works. All right, so now we got swap color. I've probably shown this to people a couple 100 times. This one is, well, we'll just copy it and show it to you. What it does is swaps. I wanted to swap like they have a swap and dupe in Forth. And I wanted to do a program that does something like that back in 2000 and that year 2000 I think it was. Anyway, so what it does is it's going to put a whole bunch of sprites on the screen. So that's what it's doing here. All the sprites it's putting on the screen. Then it does a swap color. So it swaps the color of the sprites. If you look at a sprite, you'll see it change color to another color. So it's swapping the colors. So from one sprite, it randomly picks one. It picks a random second sprite, and it swaps the 2 colors. Then I have another one in here, which is called swap character. And this now swaps the character definition for the first random one to the second random one. And then what it does is it go to back to 160 and just keeps on going. So it swaps sprite color and sprite character definition. That's all it does. It does it very quickly. Oddly enough, the random numbers, it makes it almost one color eventually. I don't know why. It's just random selection, and it just works out that way. So anyways, let's do that. Okay, then we have swap. Now this one is, I wanted to make a routine, and the routine has to work this way. I wanted to be able to swap two sprites that are going at 90 degrees of each other and change definition and color. That was the idea. So I wrote this back in 2000. And I created the swap color and swap character. That's originally what the idea was. So what this is going to do is it's going to swap the characters and colors, pretty much like the other one did, but it's just slower. And that's the swap. And then what we got here is subprogram finder. This is just a routine that I found in a magazine. And what it does is I rewrote it because originally it was an extended basic doing call peaks and call pokes or load. And I went like, well, that sucks. So let's just do it in Rxb. And this program's a lot smaller that does exactly the same thing. I guess you could stop the video and look at the routine that I wrote. You can do it right here. It's gonna do a call clear, and it's gonna go to that address. It's gonna restore that to read the data, $8, and print it. So I'll go here like that. Anyways, let's run the program. And all it's doing is it's going through each one of the headers in Extended Basic from GROM, and it's reading the addresses where it resides at, and the routine's name, and the address where it starts. So this is where the header is right here. This is that header that's in that listing, and this is actually where the program resides. I guess I can speed this up for a second, get it done. We'll go through all of them. Okay, that's done. Turn off the throttle. Okay, so that was that one, subprogram finder. This is the one I was talking about earlier. I got kind of confused. This is sprite swap, I think, what I was talking about. Okay. We'll put it in here and run it. There you see it. The two sprites hit each other, and it's actually swapping the sprite definition and color. That was the original idea, and that was the demo I created in the year 2000. So it was 22 years ago. So it's held up pretty well. It's a pretty good routine. Works pretty good. Anyways, let's go to the next one. This one is sounds, and Rxb has in it a thing called honk and beep, and these are routines from from Graham Cracker Extended Basic, which was Miller Graphics, and yeah, so it just does there's the call beep and the call honk. You can do the same thing from you can do the same thing from regular call beep or call honk. Anyways, that's what those do. Then we have the size routine. I've already shown you this size. It shows you the stack memory bytes free, the program bytes free, the assembly language. So if we go call init, then do a size, it'll show you its change. See? The assembly language size. And it shows you the locations of the SAM's memory, what pages are there, and the memory used in free. And then it tells you the VDP free address, first VDP address, the VDP stack address where it's located at, and then it also tells you the first free address in high RAM, which is 32K, the low address in up 24K. Then it tells you the RAM address is first free in the lower 8K in assembly, and the last free address, which is at 4,000. Then we have a scroll demo. I already did this yesterday, the other day. What we have here is screen. Why is it doing that? It should not be doing that. Well, that's weird. That seems to be a bug. I'll have to fix that. Anyway, save screen. Oh, that's what this is. Save screen made this screen right here. This is a routine. Let's see now. That's save screen. So we'll go with, where's the other one? Load screen. Load screen's up in L. So we have to find it. Well, it should, oh, P save? Where's it at? Well, I'm a little confused by why it's doing that. The roll demo looks okay. So it looks like I have some problems here. I'll kind of take a look at. On key, I've demoed this like 2,000 times. Brand, I've demoed. R-Motion, in case you haven't seen it. This is a reverse motion for sprites. Okay, let's do this. And this just reverses motions of sprites. Like it puts all the sprites on the screen. Then it can, after it does that, you can see it reverses all the sprites or one of the sprites back and forth. Pretty simple. See, R motion int, that sprite, else call motion all. So it just randomly chooses one of those two. Reverse one motion of one sprite or all of them, back and forth. It has its uses. Quick key, this is, this is having to do with, you can turn the quick key on and off in Rxb. Turns it on, turns it off. Simple enough. I think this is the one I was looking at here. Whoops. That's P save. Yeah, there it is. This is the one that saves the screen. So if we go here, we have a thing called P save and P load. So, new. What it does is, P save, the routine, what it does is it asks you what address in memory you want to save. And it does a 4K save to the lower 8K, and then that lower 8K is made into a file. So psave 2, which is at 2,000, then we have 3,000, but we can also do the lower upper at 24K, like 8B, A, B, C, D, E, F. Each one is a 4K boundary. So that's what this does. So let's just run the program and I'll show you. It loads up my old WindyXB that's way back before Rxb, that routine. And if I push a key, it'll save the disk. And that screen is going to be what we saw earlier, screen. That's it. That's what it saved. Oops. And because it's a program file, that's what it saved. 80 is, if you take 96 away from hexadecimal 80, that would be a 32. So anyways, that's what it did. And do we have a P load? P load here? Yeah, there's a P load. Okay, so we can do this. New. And we can go old. Whoops, can't do that. I have to load it this way. Is it the same? It's a copy of the same one. Okay, so I screwed up on big time. I wrote the name wrong. What's this? P-load is what it says. So let's load this and see what it does. I did some of these like a week ago. So it's a test of P-load and P-save. Oh, well, it's perfect. This is what I wanted to show in the first place. So you have this on the screen right now. The lower 8K to save it, then the file on disk 1, and then use that load P-load to put it on screen. So hit enter. And okay, so it cleared the screen, as you can see in the thing. What it did was it cleared the screen, call scroll down, my routine scroll down, and press any key to load screen. That's what we're looking at right now, see? So if I push key, there it goes. It reloaded the original screen that was on the screen when it did the P-save. It loaded it off disk. If we go to the file on disk 1, where's it at? Screen, there it is. View it. And you can see there's the 32s, and there's the CO line, and then we have the text down here. Here's the text that we're looking at right here. Okay, so that's done. So that's some of the routines we did. I've already done the on key I've showed before. Peek poke, everybody knows what those are. Peek grom was in the routine that for showing you subprogram. On key I've shown before. New. I have a routine for new, call new. So instead of just you typing new, you can use call new in a program. Of course, it ends the program. Moo hello. This is a demo. So if we copy this program and run it, it just says hello world, and it moves it over one step at a time on the addresses from the starting address up to the top. It's it's just a simple thing. $sign is the string that is moving. There's the $. V is the video onto the screen, because what's in string space is not the same as what's on screen. They're separate. And then it's 11 bytes. That's how long this string is. And then it's going to be $sign, of course, which is what we're putting in hello world on the screen. And then it's going to be X is the screen location right here. And then it's going to go, again, it's going to go $$9V, and it's going to go 1 byte, and it's going to be $B$, and it's going to be X+2. What that's doing is it's blanking out that line. That's what's causing it to move over 1 and then end at the end of that string. Because it's moved over 1, it would have left that letter behind. So this is blacking that out. So that's all it's doing. And then, okay, where are we at here? Move DSR. This is a view of file. All this does is just shows you how to move everything in memory onto the screen if you want to see it. And this is doing it from where? Disk controller. So it's going to turn on the disk controller. It's going to read that ROM. And what's going to do is it's going to show it to you. Everything is on that ROM. Of course, it has to use, when it does that, it has to use, it moves it into the string, then call hex has to show you the address. That's what this is right here. And then it shows the characters on the screen. And then the I.O. down here, well, the first I.O. turns on the disk controller. The second I.O. command turns it off. So, anyways. So what else we got here? We have the moves command again. This is just a demo showing you what's in VDP memory, I think. So if we run this, it's just moving everything in VDP memory right now onto the screen. It's not minusing the biases. So if there's something that doesn't have the bias on it, it'll show you those letters, which would be the same thing with the screen. Then it makes a loop again a second time to make it a single line. symbol. That's all that's doing. Then we have call motion stop. Oops. We'll copy that, put it on the screen. And here we go. This routine, all it does is it puts sprites on the screen. As a delay loop, it'll either turn on the sprites and tell them to go, or it'll tell them to stop. Stop. Then it'll tell them to go. Go, stop, go, stop. Pretty simple. So it's a new command added to motion. So here's another one. We'll copy this one in. And new, paste, and run it. This is with, okay, motion without RxB. Regular motion in a sprite will do this. Now you see how it moves all at once? Regular extended basic won't do that. If I take, paste this into extended basic and run this, oh, it's 120. Oh, I was going to call H, but we don't need this line. 120. We can take that out. Run it. Oh, 110. Oh, I can't run the demo in extended basic. It's asking for routines. Anyways, regular extended basic won't allow you to move them all at once because there'll be a delay as it goes to each one of the sprites. And what I've done is stop motion go, allow you to load all the sprites, then tell them to turn them on. Instead of just loading each one at a time, moving across, like it normally does in extended basic. So this makes it easier to move them all sprites the same so you don't end up with that jerky motion. Anyways, that's that. And I have call motion all. We saw earlier something like that. This is a different version of it. Call motion all. And it just puts all the sprites on the screen. And it's going to be a little bit jerky because of the delay between them. I haven't made it a similar language yet. Once I make a similar language, that delay between the sprites moving will be gone. This is way back in 2000 I wrote this. So that'll be improved when I go to assembly. Next version of Rxb probably. Then we have motion. This is reverse motion all, I think, or whatever. I don't remember this one. Too many things to remember sometimes. So let's run it, see what it does. Let's go with all the sprites on the screen. And, oh, it's going to call reverse motion. So it's going to call reverse motion all, or, oh, that's the same demo as the other one. All right, where are we at here? Oh, I have a new routine called mod. And mod, a lot of people wanted to mod routine because what does mod do? Well, mod does this. It gives you a, when you call mod, it's the number you want, a divisor to divise it, a quotient, in other words, the number of times it's been divided, and then it's going to give you a remainder, and that's what the mod does. So what it's doing here is it's just jumping through numbers. It's giving you, let me slow it down, it's giving you like 32,767, the divisor is 16108, the quotient is 2, and the remainder is 551. And we can speed this up. Let's speed it up a little bit, more farther the way down the list. Okay, that's good enough. All right, now we're up to numbers like this. So like 30,466 is divided by this. It's a quotient of 1 and a remainder of 552. See? So the mod is pretty useful especially if you're trying to figure out something on the screen for where it's supposed to be. That's the reason why people ask me to do it. If you have epilepsy, be a good time not to watch this one, because this is going to cause a lot of flashing on the screen. So here we go. I'm going to put sprites on the screen. It's going to change the magnification of them. And if you look carefully, you see at the same time, you see magnified and unmagnified sprites at the same time. It gives you a pretty good visual effect. But it is kind of weird to see both magnified and unmagnified sprites on the screen at the same time. Weird. Long line. This is a demo from way back in 2000. And watch this line. You can't do this in any other extended basic. And one of the reasons why is because, well, you could do it in extended basic, I think. Let's try it. Let's try it in extended basic, see if it's going to work. It might actually load it. Is it going to run it? Cool, it actually works. But you can't create this line in regular extended basic easily. It's a real pain to try to produce this in extended basic because of the redo buffer. Rxb makes it easier because I usually just call user. Call user overrides that. Anyways, so that's done. Line show, this is a program that I'm including in extended basic in Rxb. It's from extended basic, but what it was useful for is showing you line numbers. So if we go to new, it shows you the line address of a program. So we'll say no. We'll just put it on the screen. So this tells you the line number table, and Rxb is interrupting the program instead of just running it through. And the line number table, it tells you where the address at the start of the line is and the end. Now Rxb allows you to manipulate memory any kind, gram, RAM, VDP. You can manipulate any of them with Rxb because you have access to them with move. Well, the thing is though, if you have these addresses, you also know where the variable is located in the program. So you can actually modify the program while it's running. Extended Basic can modify itself while it's running. That's the reason why I included this. I think Jim Peterson was doing something like that in his Tiger Cub. JMotion I already demoed, and JLocate. I already demoed those two. So I think we're done. I'm done with this demo. So I will put it up on the screen, no, not screen, on the online, and let you guys see it. And shortly I'll release Rxb 2022G. See you later.